Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2024. Question number 5 is on the topic of forces. A safety car was carried out to determine how the speed of a car... A safety test was carried out to determine how the speed of a car affects the stopping distance of a car. At the start of the test, the car was moving slowly. Then the car accelerates at 5.8 meters per second squared. So that's the acceleration for 2.5 seconds. That's the time. The final velocity, which is given by the symbol V, was 20 meters per second. Calculate the initial velocity, which is U. Use the equation sheet. Now, the equation sheet will tell you that the acceleration is equal to the final velocity minus the initial velocity divided by the time taken. So, acceleration, let's substitute the values. Acceleration is 5.8 equals the final velocity is 20 minus the initial velocity U divided by the time, which is 2.5. So 5 times 8, 5.8 times 2.5 equals 20 minus U. That's 5.8 times 2.5 is 14.5 equals 20 minus U. So rearranging it, U is going to be 5.5 meters per second. So initial velocity is 5.5 meters per second. The reaction time of the driver was measured. How can the reaction time of the driver be used to calculate the thinking distance? Now, reaction time is just time, right? And thinking distance is just distance. So we can use the equation speed equals distance over time. If I want to find the distance, I multiply the speed by the time. So the answer would be multiply the speed of the car by the reaction time. The car was driven at a constant speed. The driver applied the maximum braking force and the braking distance was measured. The test was repeated at different speeds. Figure 8 shows the results. So here you can see a line graph. The x-axis is the speed, which goes up in 2 from 0 to 14, and the braking distance seems to be increasing exponentially right up to nearly 19.6 meters at 14 meters per second. So let's have a look at the question. Which of the following gives the relationship between the speed and the braking distance? Now, because it's an exponential graph, the braking distance is directly proportional to, if it's 1 over the speed, it's actually going to be, the line is going to go down. So because 1 over speed, the value of the speed is going to be decreasing, so the graph would actually be like that. If it's directly proportional, now this symbol, which is directly proportional, if it was directly proportional, it will be a straight line. Now, this symbol, which looks like an alpha symbol, sorry, that's the infinity symbol. You need to remember what that actually means, because we've come across the same symbol in the biology paper in 2024 as well, and a lot of students struggle to understand what that actually meant. So braking distance is directly proportional to the square of the speed. That would mean it's increasing exponentially like that. During one test, the brakes were applied for a force of 6,250 newtons. So that's the force. The deceleration, which is a form of acceleration, was 5 meters per second. That's the acceleration. The braking distance, which is the distance, here we are going to use the symbol S for distance, was 14.4 meters. Now you don't really need the symbol for distance, but we'll just leave it as S. Determine the momentum, which is rho, of the car before the brakes were applied. Now the equation for momentum using the equation sheet will tell you momentum equals the mass multiplied by the velocity. Now you need to find the mass and the velocity of the car. What you have is F and A and the distance. We can use the equation F equals ma, Newton's second law of motion. So 6,250 equals the mass multiplied by the acceleration, which is 5. So the mass of the car is going to be 6,250 divided by 5. That would give me 1,250 kilograms. So I've got the mass now. I need to figure out what the velocity is. Now for that I need to use figure 8. Now in the figure 8 I'm going to use this value, which is 14.4 meters. That is the braking distance. So let me change the color. 14.4 meters. So if I scroll back, now each box is 2 meters. So because that's 15, that's only 5 boxes. So this is 14.4 meters over here. Let's see if I can draw a straight line. Come on, straight. Nope. Need to do it a little bit faster. There you go. And at 14.4 meters, when the braking distance is 14.4 meters, we need to figure out what the speed is, which is going to be straight down. Which is 12 meters per second. So we are going to use that speed in our calculation. So the mass is 1,250 multiplied by the velocity, which is 12. And that is 15,000 kilogram meters per second. That's an easy 6 marks if you spend a little bit of time. Sorry, let me trying to figure out how to do this. Usually any question in physics, if it's a calculation, if it's more than 3 marks, it generally means that you will be required to use 2 equations. That brings us to the end of question number 5, and I will see you in the last question for question number 6.